Well, welcome back. We're in section 9-2 today. This is on factoring using the distributive property. One of the reasons why we cannot teach algebra to students that are too young or a little less mature or something like that is that we find ourselves kind of working backwards through things. And thinking backwards through stuff is challenging for all of us, but particularly for people that are a little younger or aren't used to doing it. Well, we're going to have to really focus on the ability to think backwards here. This section is entitled Factoring Using the Distributive Property. And we are actually going to use what I might call the undistributive property because we're going to be going backwards here. So let's say, for example, I had 3x times 2y plus 4, and I asked you to distribute this. I would be multiplying 3x times each of these. So 3x times 2y, 3 times 2 is 6xy, and 3x times 4 is 12x. In other words, each one of these items inside the parentheses, we distributed by multiplication. Okay, we multiplied into each of these. Notice this is an addition or subtraction problem. Now this is called the distributive property. And what we're going to do in this section is practice working backwards. So let's pretend that you didn't see this anymore. In fact, I'm going to erase this one up here. And I'm going to ask you to factor this. Or you might just think of it as undistributing. And in order to do that, we have to ask ourselves the question about what is the greatest common factor? What goes into both of these? And this is the reason you had section 9.1 in your book to cover already. What is the greatest common factor? The greatest thing that's common to both of these? Well, I see that they both have an x in there, and they both have 2, and they both have 3, and they both have 6 as a factor, but they don't have 12. They both don't have 12. So 6 is a common factor to both of these. And when I do that, this is my greatest common factor now right here. And the leftovers is what we're going to call the rest of this. The leftovers. If I was to undistribute, in other words, take something out of both of these terms, in this case I'm taking out 6x, what gets left behind? Well, let's see here. If I was to leave something behind, I'd leave behind a y, and I'm going to leave behind 2. 6xy is right there if I multiplied it back in, and 12x. This is the factored version of this problem. Now, it's not exactly the same as the last one, but we're looking for the greatest common factor. So we took out actually more than we put in on the other one. Let's do a little harder one here. All right, the instructions are going to say factor, and that's all they're going to say. And so the first thing you're looking for is there a greatest common factor in both of these? Well, sure there is. There's a 6 in both of these, and there's an a in both of these. So if I take out a 6 and take out an a, what would the leftovers have to be? Well, 6 goes into 12. Now remember, we're doing a lot of division here. 6 goes into 12 too. And if I take an a out, I'm going to leave one a behind. Remember, a times a is a squared. And if I take a 6a out of this, well, in fact, I'm taking everything out of that. So I got to leave something behind, so I'm going to leave behind a 1. Sometimes that happens when you take everything out, you have to leave a 1 behind. So how do I know if I did this right? Well, to check it, you're going to have to distribute. Okay, so we're going to distribute to check this. There's 12a squared, that's right, and 6a. There you go. So you can check these quickly by distributing. Let's try a little harder one. All right, here's a problem that's got 3 items in it. And I'm looking for each of the terms, I'm looking for what numbers and variables could I take out of each of these? What factors can I take out of these? Well, let's see. This has got a 2 and this has got a 2 factor, but this doesn't. This has a 3 and this has a 3 and this has a 3, so that might be good. I could take a 6 out of this and this, but not that. And I can take a 9 out of this and this, but not that. So it looks like I can only take out a 3 out of all of these. Also, this has a C, and this has C squared, C times C, and this has a C. So they all have at least a C. They all have one C, so I'm going to take out a C. And this has a D squared and a D and a D. They all have a D, at least one D. So there's my greatest common factor. And take a good look at that. I can't take out something if it's not common to all of them. So I can't take a D squared out, and I can't take a C squared out. It's got to be common to all of them. So once I figure out what the greatest common factor is, then I just kind of work backwards and undistribute. Figure out, well, what would it be if I divided? Well, 18 divided by 3 is 6. If I took a C out, I've taken all the C's out, so there's nothing left inside. And if I take a D out, there's going to be one D left behind. Okay? That's all we can take out of the first one. Plus sign. Plus there. 3 goes into 12 4 times. If I take a C out, there's a C squared, and we can take out one of them. I have to leave one of them behind. And if I take out a D, I take out all the D's that are there, so I'm not going to have anything else left behind. Okay? Now, let's take a 3 out of 9. That leaves 3. If I take a C out, I don't have anything left over. And if I take a D out, I don't have anything else left over. So I want to double check to see that I did this. And this is a good practice to get into. So I'm going to check by redistributing. There's 18. That's right. C. That's right. D squared. That's right. Okay. Now 12. That's right. C squared. That's right. And D. That's right. Here we go. 9. This last one. 9. There it is. C, D. So if I multiply this back in, I'll see that I did have, in fact, the right factoring. Okay? Now this is the first part of this whole process, and we're going to tackle something a little harder now. Okay? All right, everyone. You will find a copy of this called the Factoring Toolbox out in Canvas. It'll be an attachment out there that you can pull down. I think I'll probably also send it to you in email. A toolbox is a item that we use at home to store various tools in, but that doesn't necessarily mean we use every tool for every job. So for example, let's just say you have to take something. Here's a good example. You know, on in every house there's a wall plug-ins that look like this. Okay, they look like this. And right in the middle here there's a screw. And that screw's got a slot in it. Almost all of them do. It's a straight slot. And let's say you need to take this cover plate off of here and get a look at that outlet. Well, you need the right tool to take that off. A hammer won't work, and other screwdrivers won't work either. You need to have a screwdriver where the tip on the screwdriver is a straight slot. This is the one we want. There are some screwdrivers that have an X. This is called a Phillips screw. This is called a slotted screw. And to do this problem, you're going to need a slotted screw to do this problem. I'll slide that over there so you can see it. You're going to need a slotted screw to be able to do this problem. You can't use the Phillips screw. But maybe you're going to take something else apart. You're going to need a different screwdriver. Or if you have to pound in a nail, if you got to pound a nail in, it's a crooked nail there, you wouldn't use a screwdriver. You'd use a hammer to pound that in. So not every job needs every tool, but you put these tools in your toolbox so they're always ready when you need them. Well, I'm giving you what's called a factoring toolbox where you can pull the tools out as you need them. Let's take a look at it again. All right, so here's that factoring toolbox. And the thing that we just talked about here just a few seconds ago was number one, take out the greatest common factor. Our ability to take out a common factor is always the first thing that we will check when we want to factor something. Now, this factoring toolbox looks pretty big, but in many ways it's going to go by pretty quick, and you'll figure this out pretty fast. But there's really only a few tools on here. Let's count them. 1, 2A, 2B, 2C, number 3, and number 4. That's 1, 2, 3, 4, 5, 6 tools. And today we just talked about number 1 already, that ability to take out the greatest common factor. So today we're handling number 1, and so you could circle that on your sheet. But I also want to talk about this one called factoring by grouping. It's letter 2C. We're going to talk about that one right now. All right, let's tackle factoring by grouping. I'll go over several of these, but you can keep looking back at your factoring toolbox to see how these are done. Now, factoring by grouping is a process that we use when you can't take something out of every term. So, for example, let's do a problem, simple problem. 4AB plus 8B plus 3A plus 6. Now, the first thing we have to do is be able to recognize when we need this tool, just like you have to be able to recognize when you need a slotted screwdriver and when you need a Phillips screwdriver. I can see that I can't take something out of every term. I can take a 2 out of here, but not here. And I can take a 3 out of here and here, but not these. And I can take an A out of these two and B out of these two. So I can't take something out of every one. So that tool number 1, greatest common factor, can't use it. But there's a couple things that will help me recognize when I can factor by grouping. The first item you want to look at is there 4 terms in the problem? 1, 2, 3, 4. If there's 4 terms in the problem, then it causes us to ask the second question. Do we see a ratio pattern? Let me show you what I'm talking about here. A ratio. I'm going to underline the first group, and I'm going to underline the second group of 2. And I want to show you a pattern here. Look at these numbers. 4 to 8, well, that reduces 4 to 8. That reduces to 1/2. And 3 to 6. Oh, 3 to 6 also reduces to 1/2. So it's possible, because there's a common ratio, 4 to 8 and 3 to 6 gives me the same ratio, that I can factor this by grouping. So this is the thing you're going to be looking for. Do you see 4 terms? And if you do you see a ratio that is shared between these 2 groups? You notice I've got 2 groups and they're both underlined. So we see, in fact, that we can factor this by grouping. So as we look back at your toolbox there, step number 1 is to do what I just did, underline the 2 groups. You might have that toolbox right in front of you so you can watch it as I'm doing this. All right, step 2 says take the GCF, the greatest common factor, out of this first group only, just this one. Well, I can see that there's a 4 and a B in both of these. And when I take out 4B, I'm left behind with A plus 2. 4AB plus 8B, that's right. I'm going to take out the greatest common factor out of the left group here. Okay, so the first step, underline. Step 2, take the greatest common factor out of the left group only. All right, step 3 is to do some copying. These are called the leftovers. We called them that before. We're going to copy the leftovers over here to the right. Copy the leftovers under the right group. Leave a gap in the middle here. I'm just copying. That's all I'm doing. Copy those leftovers over here to the right. Okay, that was step 3. So step 1, underline. Step 2, take the greatest common factor out of the first group. And step 3, copy the leftovers over here to the right. Okay? We're almost there. Now, we've got 2 more steps. The next step is we have to ask ourselves a question. Looking at this second group on the right here, what must have come out to give me those leftovers? What did we have to take out of this first group, or excuse me, this second group, to give you these leftovers? 3a became a. What came out? Oh, it's a 3 that came out. 6 became 2. What came out? 3. Yeah, 3 came out of both of these. So we ended up pulling a 3 out of both of these terms. A 3 came out of both of those. So I'm going to write that right in the middle here with a sign of the number. It was a positive 3. Don't forget to write that sign. Positive 3 came out, and there is the number that came out. Now what we did is we factored this group, and we factored this group, and they both had the same leftovers. Now, if you recall foiling, what we're really doing here is we're unfoiling this problem. If both of these are multiplied times a plus 2, then I can actually marry 4b and 3 together and marry a plus 2 together. Now, these are what I call the marriages, okay? These two are going to hold hands, and these two shall become one. Okay? These two are holding hands, and these two shall become one. Now, you have just unfoiled this problem. Remember, first, outer, inner, last. Well, that's what we had here. First, right? First terms, outer terms, inner terms, last. We just unfoiled this problem. So this is our answer. This is our answer right here, that we have just factored by grouping this 4-term polynomial. Now, how do I make sure I did this right? Well, to check it, I'm going to FOIL. So I'm going to FOIL this just to make sure it's right. So here we go. 4b times a is 4ba, or for 4ab. Outer would be 2 times 4b, or 8b. Inner would be 3a. And last would be 2 times 3 is 6. Yeah, that's what I had originally. So this checks. This is exactly the right thing to do. In factoring, you can often just refoil something to figure out if you factored it right. Now, those are the 5 steps. They're on your sheet there. And let's take a look at them again. Okay, here's the sheet. We're going to take a look at those 5 steps that we just went over. Here they are under 2C, right here. Underline the 2 groups. Take the GCF out of the left group. Copy the leftovers under the right group. Ask that question, what must have come out of the second group? And then number 5, marry the 2 groups. Keep this sheet right to the side there, because we're going to do some more here, a couple more. All right? All right, let's do another one. And I'm going to think myself through my factoring toolbox. And step 1 is greatest common factor. Should I use that? Well, let's see. I can take a 3 out of this and this, but not these 2. And I can take a 5 out of both of these, but I can't take something out of everything, not even a variable. So then I'm going to say, well, maybe I can factor this by grouping. Are there 4 terms? There are. 1, 2, 3, 4. Let's underline the 2 groups and see if we have that ratio that I talked about. Okay? Common ratio. Well, this looks like it's in a ratio of 15 to negative 3. Well, 15 to negative 3 is like 5 to negative 1. Okay? How about this one? Well, this is in a ratio of 4 to negative 20. Well, that's in a ratio of 1 to negative 5. Well, it's almost the same ratio. What if I just turned these 2 terms around And then I would have that same ratio. Let's turn it around and see what happens here. Turn these two around. Now let's see what my ratio looks like again. Okay, we're checking the ratio out. 5 to negative 3, 5 to negative 1, negative 5 to 1. Let's turn this upside down. So negative 20 to 4 is negative 5 to 1. Yeah, these are the same ratio. Now, some of you say, well, the negative's in the wrong place. Well, remember, it doesn't matter whether I put the negative on the top or the bottom. So they are in the same ratio. So we're going to underline the two groups. And what this tells us is sometimes we may have to turn some around in order to see what that ratio is. Had to turn these two around so that I could see it. That happens every once in a while. All right, let's take a look at this first group. What can I take out of the first group? Remember that first step, greatest common factor. I've underlined the two groups. Now I want to take the GCF out of the left group. Okay. Well, what comes out of this? Well, a 3 will come out, and so will A. And that leaves me with a 5 minus B. 15A minus 3AB. That's right. Now, don't think about it. Just copy the leftovers to the right here. Don't think about it too much. And ask yourself, what has to come out of the second group to leave you these leftovers? Well, it looks like negative 20 divided by what would give me 5? Well, that'd have to be a negative 4. I'm going to put that sign there with it. 4 divided by what gives me negative 1? There's a 1 right there, isn't there? So negative 4 had to come out of both of these in order for me to get these leftovers. So there you go. We found out what comes out of both this left group and the right group to give the same leftovers. And finally, the last step here, so we asked the question, what must come out of both groups, of the second group? The last step is to marry the two groups together. Well, all right, these two guys are going to hold hands, put them in parentheses, and these other two are going to become 1, 5 minus B. So there it is. Now I could check this again by foiling it to check it. 3AB, 3A times 5 is 15A, there it is. 3A times negative B is negative 3AB, there it is. Negative 20 is right there, and positive 4B. You'll notice that we have two negatives gave us a positive here. All the signs worked out correctly. Okay, let's try another one. All right, let's do another one here. Now, can I take something out of every term? Greatest common factor? Nope. So I asked the question, now maybe it can be factored by grouping. Well, there's 4 terms, that's good. And if I underline the two groups, do I have that ratio? Well, there's 35 and 3, and these numbers might make sense. Maybe I can try turning something around. In fact, why don't I turn around these two in the middle? Let's turn those around and see what happens. 35x minus 5xy plus 3y minus 20. Just turn those two around and see if you got a ratio here. Oh, looky here. We got a ratio of 35 to 5. That's 7 to negative 1. And this one is 1 to negative 7. Let me turn these around also. Let's turn it around also. So I got these in different order here. Now let's check out the ratio. Okay. 35 to negative 5 is in a 7 to negative 1 ratio. And then this is negative 21 to 3. That's in a negative 7 to 1 ratio. That works. So this is the right order that we're going to need to factor these. Now I could have probably turned them around in a different way. It might have been a little shorter. But this is what we ended up doing. So let's take something out of the first group. Remember, your first step is to underline the two groups. I'm going to take something out of this group. And it looks like a 5 comes out and an x. That leaves me with a 7 minus y. 35x minus 5xy. That's right. Now, copy the leftovers to the right. Copying them over, just copy. This is my next step. So underline, take the GCF out of the first group, GCF, then copy the leftovers over to the right. Finally, or not finally, but the next step is, what can you take out of this that will give you this? Well, negative 21 divided by what gives me 7? Well, that would be a negative 3. 3 divided by a negative 3 is a negative 1. So this is correct. So I have to ask, what had to come out of the second group to give me these leftovers? Now you're going to need a lot of practice on these to accomplish this. All right, let's marry these two together and marry these two together. Usually the problem we have is not that people can't get the marriages right, it's that they can't figure out what to take out of this second group. That's usually the problem. Let's try one more, and then I'm going to cut you loose. All right, let's take a look at this one. This happens to be one of the problems from your homework. I want to try to take something out of every term if I can, greatest common factor, but I can't. I can't get a same number out of every one of these, but I do see that there's 4 terms here, so maybe I can factor this by grouping. Let's find out. I'm going to underline these two groups and see what my ratio is. 5 to negative 15. Well, 5 to negative 15 reduces to 1 over a negative 3. And 4 to negative 12, well, that also reduces to 1 over negative 3. So that is the right ratio, just the way it's printed there. So we're going to go ahead and factor this. What comes out of this first group? Well, let's take out 5y. And what we leave behind here is a y. And if I take 5y out of this, I get a negative 3. Negative 15y. Okay? Now, copy the leftovers. Don't think about it. Just copy them over here. And then say, what had to come out of this group to leave me with these leftovers? Well, it looks like I had to divide by 4. 4 divided by 4 is 1. Negative 12 divided by 4 is a negative 3. And you'll notice you've got to have that plus sign there. Don't forget to put that in there. The sign of the number needs to appear right here. So we marry these together. I get 5y plus 4 and y minus 3. Now, you'll have to come back and watch this over and over and over again until you can figure out these 5 steps in order. Make sure you keep this sheet handy so that you've got it always close by. So today's assignment, you're going to be dealing with number 1, take out the greatest common factor. And if you can't do that, then you're going to do 2C, which is factoring by grouping. And all the instructions are right here. So I will leave a copy of that for you on Canvas, and you can also, I'll send it to you in an email attachment. Let's take a look at your homework for tonight. All right, so here's your assignment for tonight. And this is an absolutely critical concept. We might spend 3 days on this. It's that important. Maybe just 2, but make sure you practice this factoring by grouping. Keep your factoring toolbox close at hand while you're working. Follow those steps on number 1 is greatest common factor, and 2C, the factoring by grouping. There's your homework for tonight, and I will catch you for the second half of this assignment another time. Take care.